I remember in my geology course at Queensland University, our dear old professor walked in one day and he said, "Students, I'm sorry, the rocks in the Grand Canyon get old sideways." Now, that was a bit of a radical thought to me. And the trouble was, he never said another word about it. For the next 4 years, when I left, he still hadn't meant. Why did he think that? Well, see the Grand Canyon? I've been there many times, climbed up and down there about 10 times. I know the rocks pretty well. You see the comment I've made? The professor said the rocks layers got there sideways. The ones at the top are older than the ones at the bottom. Now, having been there, I've got to agree with him, even if you only use the fossils. But of course, that throws everything we base evolution and old Earth and the whole gap theory and everything, it turns it upside down. Okay, question. Have you ever started off at the beginning? Because sediments only get there with water, and water erodes. But only moving water carries mud and sand. And then it only moves sideways. Isn't that so simple? You should have done that in primary school, in elementary school, in high school. You should have been reminded of it in first year geology. Water moves sideways. Therefore, the only way rocks can grow, they must grow in the direction of the current. The bottom layer, therefore, does not get there first. This is so simple, it's regarded as stupidly wrong. But in reality, I've sat in big rivers, I've sat in bays, I've sat there during flood time and watched the water do exactly that. The left side is older than the right side if that's where the current is coming from. Therefore, the top layer, can it be the youngest? The answer is no. The left side will be older than the right side. Which brings us back to Jurassic Ark. Now, when Joseph was a single man, we brought him to Australia because we can't bring just about anybody to Australia now because of COVID. But here he is in one of our models, one of our early models of our strata machine. I think it's model number 6. There's Dianega. And we're measuring the water flow and noticing a few things. You'll see our primitive bath source of water. You'll see our rocket scientist Clem acting as the pump inducer there. Okay, so now we have kids who are always fascinated by water. And yes, we have mentioned this a few times, but you need to get this principle. There's the river flowing from left to right. Now, initially, this looks like it will only apply to rivers and only apply to bay mouths. But you watch what happens. Okay, here we are. The layers have formed from left to right. When you look, the time taken for those multiple layers to form is 2 minutes. And they're actually forming sideways. We sat there, we watched them. And then when we filled up the whole tray, we did something. Or we cut it so you could see inside. You see the layers on the outside alongside the perspex continue along on the inside. And then we actually had an erosional event. Now, do you see something? Does that look like something you've seen before? How about what these students are sitting there? Sure it does. And my professor said the layers in the Grand Canyon get old sideways. But yet I've been there, I've sat through the guided tours, I've gone and done our own research, I've walked up and down, got some really good exercise, great for the heart, and it's on the signs, it's from the tour guides, it's in the museum. The bottom layers are older than the top. But you see, my prof turns out to be right in every situation. I mean, is this just a giant flume tank? Well, I think it is. The professor obviously thought it was, but didn't want to comment because it makes everything go head up. It tips them topsy-turvy. It's not vertical time, but horizontal process. And what's this based on? Yes, not just my professor, but it's based on a presentation I gave to the Oxford Geological Association. Now, Sam, if you will just bring me back on screen here. There's young Joseph and there's older me. And here's where we were, right down near the Bristol Channel. I love the GPS on your phone because you can actually prove exactly where you were, right? Now, when you have a look, I was at this site because for many years, 40 years ago, I visited this site to collect dinosaur fossils, yes? And there's all sorts of other fossils there. Oh, what are we collecting on that day? Can you actually see the scallop shell? There is no doubt about it. scallops are still the same today, even though these rocks are supposed to be in the hundreds of millions of years of age. We've taken field trips there over the years. But what's interesting is they have signs up there that tell you about this field trip area. I mean, look at the pictures of the layers there, and they give you names for the layers. The red ones are different from the green ones, and then they have a story about this, how over time it became a drowned desert. The red stuff at the bottom is a desert that was buried by the watery stuff that came in at the top. Now, I don't know about you, but I live in a country where there's lots of deserts, and they're usually very dry. If we call it drowning the desert, then we talk about floods. But floods is not an in word still in most people's mind, because the reason Charles Lyell got underway was his aim was to remove Moses from science. Moses, creation. Okay, now all of this is generic, and you can say, well, John Mackay, you're just a good storyteller. And there's no doubt about that is true. That's why kids love our storybooks on Noah. I love telling stories, always have. But what about the stories for the big kids? When I first went to this area many, many years ago, I picked up from the Geological Association the guides to the area. You'll see the Bristol Channel there on the left, the unmarked area. You'll see the red line, which is the cross section we're going to look at, because in the textbook, it's actually allocated there. All right, now you see the big pink one that shows up at the spot. Then you've got all these other layers. The bricky ones are limestone. The sort of dotted ones are sandstone. And then you've got a section at the top. And the evolutionist explanation is this took millions of years. So there was my challenge. Okay, here is a section that my professor, based on what he said at the Grand Canyon, would have said, this has been formed sideways. But I have a sideways machine. We invented it. And by the time we get to testing this one, we're up to Mark 10 strata machine. Yes, research is expensive. We're now up to Mark 11 or 12 because a big storm smashed that one to pieces. Okay, so here we are, 2019, with the Mark 10 strata machine. Or you can see the sediment coming in with the flowing water at the right-hand side. You can see a layer there. Let's go closer up. Now, what's happening here? You can actually see the water flowing uphill on the right. You can see it flowing with level at the top, and you can see it bouncing along with curves. And actually, if you have a close-up look at that, can you see all the strata that's formed? Now, this is one current always flowing in the same direction. Look at this. One of the things we've observed, look at the right-hand side, just at the top. The layers there are not forming horizontally. They're actually forming parallel to the surface of the current. You know, I'm rewriting Steno's rules, that the law that says the layers form on the bottom first and they always form originally horizontally. I've decided that is nonsense. The layers in any deposit will form parallel to the surface of the current. I mean, look at the ones at the bottom. You see these nice curved ones? None of this sediment has been moved by uplift. This sediment has always been forming from right to left. And when it's been going topsy-turvy, it's formed current layers that are topsy-turvy. Nothing got moved around by any tectonic plate movement. Okay. Now, all that there, the sediment was coming in one. Oh, look, you can even see the top much clearer here. On the right-hand side, you will see the sediment is always forming parallel to that top of that wave. Quite amazing. In other words, you can say the anticlines and the synclines, these are the ones that go with geology or with the gravity or against it, uphill or downhill. None of them are due to subsidence or uplift. Now, the only thing we've done is actually vary the speed of the current, because that's what happens every day in a tide. And I sat in Washington State and watched a flood. Yep, I sat there for 3 days. I did go home for a bit of sleep, by the way, but I photographed the water coming down. There's no doubt about it. The flood would be vicious, and then it would slow down a bit. Then you'd have massive rain again, and you get bigger water coming in. So the speed of the current varied. Can you see what's happening? We are getting incredible deposits. And all of that, what looks like anticlines and synclines below it, is now got an opposite thing sitting on the top. And the water is still going in exactly the same direction. All that's changed is the speed of the current. Now, we are not taking millions of years to do this. We are not taking hundreds of years. It's undeniable. The beds are forming parallel. I mean, look at that. Flat at the top on the right-hand side. Then as it goes over the hill in the current, it's the current which is determining where the bed is, not the bed determining where the current is. All right, now let's go. There's the bottom. That's the cross-section out of the map guide from the Geological Association. What you've got at top is our section in the strata machine. The bottom one, according to the experts, took millions of years. Are you ready? Are you up to coping with the next bit? Have you taken your blood pressure pills on your heart tablets? Because the top section took 20 minutes. And all that happened, we didn't change the content of the sediment. We actually changed the speed just 2 or 3 times, because that's what we see in the real world. In bores like the Bristol Channel, when the tide comes in or out, in storms, even in tides, with wave surges, in tsunamis. Again, can I stress one thing? There's the principle we've been using in geology at Jurassic Ark. Teach the students, taking the schools. The issue involved here is not time, but process. And if you get the wrong process, like the sediments at the bottom got there first, shake up a cup, watch the sediment, students, settle down, that is not the right process. No wonder you think it took millions of years. You see, the problem with most geologists, and the problem including many Christians, is they got the scale of Noah's flood and the wrong process. They picked the wrong process. Now, if you want to see some more of this research, then go to creationresearch.net, click Exciting Research, and then search the rock layers. We've just posted up the program we did a few weeks ago as almost like a PDF, and you'll see the pictures there for your own. You can examine them for any length of time you like.